A new and promising solution for mass transportation is here. A solution that will solve most traffic problems. Introducing the newly patented interconnected suspension structure for elevated monorails. But wait, what is this all about? According to the United Nations, the urban population has more than quadrupled since 1950. By the year 2030, 60% of the global population will live in cities, and as these urban centers all over the world grow exponentially, the number of people that commute to and from work will also be increased, requiring more and more means of transportation. As people spend more time on crowded roads, the loss of time and increased stress negatively impacts the economy. The streets are full of cars and buses, with no room to spare. One solution is to build underground subways. However, this costs 9 to 10 times as much as light rail, and its construction is significantly slower. Another solution is to build above traffic. But these structures are massive. The columns that support the tracks occupy a lot of space from the street and the sidewalk, and the tracks themselves block the sunlight and the sky, and therefore immediately decrease the value of properties below, making for an unsightly view. Problem solved. Instead of a bulky and inconvenient structure in your city, you will see the newly patented interconnected suspension structure for elevated monorails. But how does it work? This invention uses the time-proven structure known as a suspension bridge, which has been around for hundreds of years. More than half of the bridges of the world are suspension bridges, because of their simplicity, low cost and ease to build. Let's see how it works. A suspension bridge consists of a main cable anchored at each end, as well as vertical suspender cables that carry the weight of the deck below. The cable is suspended between two towers. The main innovation is to move the two anchors to the sides of the towers, and keeping the cable on both sides with a beam, and then interconnecting the neighboring segments to that same tower, placing the anchors on both sides. The adjoining segments are very important because without them, the weight of the deck will bend the towers inwards, collapsing them. Once the segments are interconnected, the structure is duplicated, and the cables of each segment are intercrossed. This intercrossing supports the track and creates a strong structure that adds a lot of stability from lateral motion like wind, as well as movement within the cars due to curves on the track or passenger movement. This makes the track very stable and solid. The main towers are then joined together with girders. The track below is supported by sleepers connected to the main cable by vertical suspended cables. And the main cables are connected to their respective anchors with a series of triangular beams. So, this is how it might look in the future. Above all the traffic, monorails circulating on unobtrusive, unassuming tracks, silently and without obstructing the sky. Having no impact on the traffic or sidewalks below, they can transport hundreds of people safely to their destinations, while at the same time, being pleasing to the senses. The cars hang from a hinge-like joint, or swivel that allows it to sway without generating stress on the track above. This movement is kept under control by using shocks on both sides of the articulation. The power comes from two insulated contact rails located underneath the track. There is no need for a pantograph or a third rail. These contact rails are connected to the car by metallic shoes or wheels, which transfer power to the electric motors. Turning corners can be achieved by simply terminating the segments by placing two towers coupled together, then connecting a series of 3 cables, one in between the two sets of towers and 2 of them to a third tower on the opposite corner, and then placing hanging wires suspended to the curved track below. The tower on the opposite corner is supported by 2 anchors on each side. This creates solid support on 3 points of the track, allowing the trains to turn corners without expensive support structures or massive beams or girders. This new structure can solve most public transportation problems because it minimally impacts the streets below, requires a minimum of materials and is quick to build, which makes it very cost-effective, solving all of the problems that plague elevated trains, as well as being safe and sightly. For more information, please visit emonorail.com or contact info@emonorail.com.